Okay, trying round number 2 on my new toy. The pen is working now. I tried it at home, it didn't. So now I'm at school trying it today. And this next unit, we're going to look at a little introduction into functions, function notation, graphing functions, and so on. So today we're just going to look at graphing functions using a table of values. So in order to do that, what we're going to do is set up a table for x and y, and just pick some values for x that we'll plug in, like -2, -1, 0, 1, and 2. And just to start with some values, so we're just going to substitute these values in for x and find y. For example, when we substitute -2 in for x, we just follow order of operations. So -2 times -2 is +4, plus 1 is 5. So when x is -2, y is 5. So what that gives us is an ordered pair that is on the graph. We know that this graph goes through the point -2, 5. Okay. Now the same thing when we plug -1 in for x. -2 times -1 is +2 plus 1. So then we have 3. Okay. So then the point -1, 3 is on the graph. If we plug 0 in for x, -2 times 0 is 0, plus 1 is 1. Same thing with 1, -2 times 1 is -2, plus 1 is -1. And -2 times 2 is -4, plus 1 is -3. So, to graph this, we will set up our, and we're not real concerned with being real precise with this, but just to give us an idea of the look of this graph, we're going to plot these individual points. So, for example, the -2, 5 would be about there. The -1, 3. The 0, 1. 1, -1. And the 2. And then we'll connect them, because x in this case can really be any kind of number, fraction, decimal. So we'll just connect those dots, and these just give us an idea of the shape of the graph. So I will get rid of that stray line there. So now a set of values, or to set up a table of values for the second one, we will again pick values for x. Now I'm going to pick some values for x that make it relatively easy to work with. Since I'm going to be multiplying these by 1/2, I'm going to pick some even numbers so that I won't end up doing any addition or subtraction with any fractions. So I'm going to pick all even numbers. If this were, for example, 1/3 x, I might pick nothing but values or multiples of 3, and so on. So pick values that are fairly easy to work with. So I'm going to pick, for example, -4, -2, 0, 2, and 4. Because if I pick odd numbers, I am going to end up with fractions to work with, and I know you guys don't care to work with fractions. So pick values that will work out nice. So if I plug -4 in for x, 1/2 times -4 is -2. Minus 1 will be -3. Plugging -2 in for x, 1/2 times -2 is -1. Minus 1 is -2. Plugging 0 in for x, 1/2 times 0 is 0, minus 1 is -1. 1/2 times 2 is 1, minus 1 is 0. And 1/2 times 4 is 2, minus 1 is in fact 1. So to graph this, we will just plot those points to give us an idea of what this graph will look like. So for example, -4, -3 would be about down there. -2, -2, 0, -1, 2, 0, and 4, 1. And again, we have a line. Okay. In the next two examples, we are going to look at some special functions. The first one is an absolute value function. Again, we can pick several values for x just to get a general shape. For example, we can pick -2, -1, 0, 1, and 2. So if we plug -2 in for x, absolute value of -2 is 2, minus 4 is -2. Same thing with -1, absolute value of -1 is 1, minus 4 is -3. Absolute value of 0 is 0, minus 4 is -4. Absolute value of 1 is 1, minus 4 is -3. Absolute value of 2 is 2, minus 4 is -2. So to give us a general idea of this shape, and to put these graphs in, or put these points in, point -2, -2, about in that area, -1, -3, 0, -4, 1, -3, and 2, -2. So this absolute value function follows a V shape for that graph. Now with D, again setting up the table of values, and again I'm going to set up pick values -2, -1, 0, 1, and 2. -2 squared is 4, plus 1 is 5. -1 squared is 1, plus 1 is 2. 0 squared is 0, plus 1 is 1. 1 squared is 1, plus 1 is 2. And 2 squared is 4, plus 1 is 5. Now, you'll see the same thing kind of happening with the absolute value. However, it is a little bit different with this one. This one we call a quadratic function, and we are going to be working a lot with quadratic functions later on. So in plotting these points, -2, 5, we'll put about up here, -1, 2, down here, and 0, 1. And then we've got 1, 2, and 2, 5. Okay, not really a V this time, but more of a curved shape. We call this shape a parabola. But that's what the graph of that function looks like. Tomorrow we will talk about finding the domain and range of these graphs and so on. In this one, we have a word problem that says the function rule W is equal to 146C plus 3,000. This represents the total weight that a concrete truck that carries C cubic feet of concrete. So if the capacity of the truck is about 200 cubic feet, what is a reasonable graph for this rule? So we're going to pick values for C and find the weight for that. And again, the maximum weight we can do is 200, so, you know, maybe we go by 50s. And calculate the weight. Let me grab a calculator here. So when we substitute 0 in for 100, or in for C, 0 in for C, 146 times 0 is 0, plus 30,000. So what this ordered pair means that if the truck were not carrying any concrete at all, the weight, total weight would be 30,000 pounds. If we plug 50 in for C, 146 times 50 plus the 30,000, the total weight of the truck would be 37,300 pounds. And then if for 100 cubic feet of concrete, 146 times 100 plus the 30,000, the total weight of the truck would then be 44,600 pounds. And if we substitute 150 in for C, the total weight of the truck would then be 51,900 pounds. And if it was filled to capacity, 200 cubic feet of concrete, the total weight of the truck would be 59,000 pounds, 59,200 pounds. So then the graph of this, if we set up our graph, we will put the cubic feet of concrete on the horizontal axis and the total weight of the truck on the vertical axis. So again, the capacity is just 20, so if we go by 50s, and on the vertical axis, the weight, we got to go up to at least 60,000. So if we go by, say, 15,000, so to finish this off, at 0 cubic feet of concrete, we're at 30,000. At 50, we're at 37,300, which is, you know, almost halfway between 30,000 and 45,000. At 100 cubic feet, we're up to 44,600. At 150, 51,900. And finally at 200, we're up to 59,200. So the reasonable graph for this, now notice I don't put an arrow at the end of that because the capacity is only 200 cubic feet. It's not going to go on forever. So that's what that graph looks like, and it is pretty linear. It will turn out to be linear and as precise as we can be. In the next video, we're going to talk about the difference between a continuous graph and a discrete graph.